All right. Now let's try a continuity question. So determine the value of k so that the function's continuous everywhere. Okay, so remember one very important condition to be satisfied when we're considering continuity. The limit as x approaches -1 in this case of f of x must be equal to f of -1. And of course, there are other conditions as well, right? It must be that f of -1 is defined. It must be that the limit as x approaches -1 of f of x does exist. And the third condition is this one right here. So we need to make that happen. So first of all, let me just figure out the limit as, I said f of x, but we got the g of x here. Oh well. So limit as x approaches -1 of g of x. Let's figure out what that is. Well, when x is not equal to -1, so both from the right and the left, or x as x approaches -1 from the right and the left, the limit will be the same. And that's a good thing, because then it means that it does exist. So let's try to evaluate this. And we can, because I can actually just factor x squared minus 1 to x plus 1 times x minus 1. And then, of course, we can just cancel these out. Whoops. Got a wrong color there. So these cancel out. And then I can actually plug in the -1 for x. So the limit as x approaches -1 is just going to be -1 minus 1, -2. Do I have room here? So the limit as x approaches -1 of g of x is just -2. Great. Now, it must be that the limit is equal to, well, in this case, I said f of -1, but we need to make that equal to g of -1. So g of -1 must be equal to -2. And we know that for the function g of x, when x is equal to -1, we got 2k. So this is equal to 2k. And 2k must be equal to -2 then. So we can divide both sides by 2. So k must be equal to -2 divided by 2, which is -1. So it looks like that if k is equal to -1, this function is continuous everywhere. And why is it continuous everywhere? Because remember that for any polynomial, in this case we got just a linear function, x minus 1, the function is continuous everywhere. The only point where we were concerned would be when x was equal to -1. But then, since k is equal to -1, we actually filled in that point of discontinuity, and now the function is continuous everywhere.